Paulo Tuminelli said that car design is not so much about creating an industrial style as fulfilling needs. This means that you're just designing the product based on what the customer needs.
Our final project consisted of redesigning a toy pullback action car. We were able to purchase this mini truck, and it is pullback action. It's plastic, mainly made of a spring gear-driven gearbox. And as you can see in the pictures, this is one assembled, and there's several parts here that shows the disassembly of the truck and what we use throughout our project to help us redesign either the aesthetics, the looks of the body, the gearbox, and even the wheels. And as you can see here is the actual cars that we used throughout our project, and some of the requirements was to consider some changes made to the toy car throughout the project. And our next slides will show various things that we did on our redesign.
Today, core must function, and you need to think about it no matter what your company makes or sells. Alan McGrath. The first part of the redesign was to redesign the aesthetics of the product by remaking the outer body of the car. The first thing to do was to add additional features such as the chrome grille and bumpers, the chrome fender wheels, and the chrome lighting at the top. And on the real products, these would all have to be stickers because you can't plastic inject and mold all the different colors, so you have to apply stickers to each feature. And this would help to save materials because you would use less plastic, and it would also help to reduce costs. And it would help you to also customize the vehicle. And the same thing goes for the lights. This is the back view of the truck. You can also see the rear lighting and the chrome bumpers.
This slide brings us to the redesign of the wheels and the axle assembly of our toy pullback car. When it came to redesigning the wheels, we chose to go with a more open wheel design and a more modern look with the polished aluminum and then the rubber treads that assembles to the wheels. We give it a tractor, rough, tugged look, and then the axle. And according to hands-on science, this is a fixed wheel, fixed axle assembly, and the axle freely rotates inside the body for the car to actually take motion.
This brings us to the gear assembly and the drive mechanism for the car. You can see here that we have 5 gears. The gear ratio for all 5 gears is approximately 2 to 1. Most gears in the assembly have 18 gears with a corresponding mating gear with 9 teeth. So this is approximately a 2 to 1 ratio. And we decided to keep these ratios the same, and you will find out later on how we changed the car to increase speed. And here you can see the final assembly for the gears with all covers and everything assembled to the drivetrain. Here's an exploded view of the gearbox. You can see each gear and how it corresponds to the outer and inner covers and how they would all go together. And here is the hole for the axle to protrude through, and there will be another gear that will mate to the gear assembly, and that will drive the mechanism.
Part of our redesign process included redesigning the wheel diameter to increase the speed of the car. We lowered the wheel diameter to 1 inch, which was smaller than the original design, kept the same gear ratio, which was putting the same amount of force and power into the axle and wheels, but in return increasing the car's speed.
The final product was created by combining each element of the redesign process into a final assembly, combining all the body, the wheels, and other pieces. Here you can see the inner workings of the car with the drivetrain, the wheels, and the axle assemblies. And here are each sub-assembly going in together in an exploded view for the final product.